To be able to provide good Wi-Fi design, you will often need to use directional antennas, especially in certain environments. Now, most of extreme wireless cloud access points come with integrated antennas. They will have a predetermined radiation pattern, which you can see on the data sheets, and they are normally designed for ceiling mount, omnidirectional type of deployments. In other scenarios, you will need to direct that signal. You don't want that signal to be lost either by going up into the ceiling or going left and right too much. You want to direct that signal in a certain direction. That's when we use directional antennas. And to use directional antennas, you'll need to couple them with one of the access points with an X next to their name. So AP122X, AP245X, or AP510CX. There's different types of directional antennas, and they will, like all antennas, they will differ on what frequency band they support. They will differ in how they direct the signal. We call this how they attenuate the signal, or most often it's going to be determined by the signal radiation pattern will show you in what direction, in terms of degrees, the signal is directed. And the attenuation will directly reflect that radiation pattern as well. So are you going to go into all directions around the 360 direction, or you're talking about 60 degree, 90 degree, 180 degree directional antennas? So how do you decide between those? Well, it depends on what kind of environment you're deploying them in. In some cases, so if you're deploying, for example, in an auditorium, or you want to direct the signal down the hall, you probably want an 180 directional antenna, which will send the signal in 180 degrees, basically from the wall you're deploying it, all the way down to the corridor. Or same thing, if you deploy the AP and the antenna up high on the ceiling, you want to direct that signal down, but in all directions, and you don't want to lose any signal going up into the ceiling itself. In some cases, you want to direct the signal even more, so you will have a 60 degree or a 90 degree antenna, and that in those cases we're talking about environments like warehouses, where you want to direct the majority of the signal in a very narrow direction, usually down the corridor between the shelves. That will determine what kind of antenna do you have to choose. So you choose how directional the antennas actually are, how much do they direct the signal. You select the frequency band, and one important consideration as well is, are the antennas MIMO capable or not? So if you have MIMO access points where you have multiple radio chains, you need to find antennas that actually work with those access points, that also provide MIMO capabilities. And the importance here is the distance between antenna elements needs to comply with the rules of MIMO, otherwise you break the MIMO system. Extreme wireless cloud, we do provide directional antennas as well, so you can select from a range of directional antennas when you're buying 122X, AP245X, or AP510CX access points. Let's look at a warehouse scenario. So in a warehouse, in the picture on the slide, you can see a warehouse with shelves going top to bottom. And in a warehouse scenario, usually you're not so much worried about capacity as you are with coverage. Now, even providing coverage in these scenarios can sometimes be tricky, because there's a lot of metal on the shelves. Sometimes the contents of the shelves will include liquid, and in one way or another, they will block out all of this signal from the access points and from the clients, interrupting the communication. So in this case, the device population are usually handheld scanners, and those devices, typically they have pretty capable radios. They will have good receive sensitivity. They will be able to pick up the signal better than your average smartphone. And A common deployment will also be voice over Wi-Fi, and sometimes these terminals are also mobile because they are mounted on the forklifts and they move around quicker than a person would when they're walking. So that creates a different roaming consideration. Because a lot of warehouses have very high ceiling and also there's limited access to the ceiling, the coverage is often provided by directional antennas mounted on the walls at each side of the shelves. Now that depends on the warehouse itself. In some warehouses you will be able to get away by mounting access points with directional antennas on top of the aisle, whereas in other cases the aisle may be too long and you'll need to provide directional antennas at either end. And the number of APs will obviously change. The most important consideration in this design is you will have to do a site survey, use different types of antennas and experiment how do those different types of antennas affect the Wi-Fi signal going down the corridors, going down the aisles, and also when you're deploying these APs, how will that affect roaming in case you have Wi-Fi clients mounted on forklifts, for example, because they will move faster than an average person would walk with a handheld scanner. Many aisles are going to be very long, and you may even need to combine ceiling mounted access points with access point with directional antennas on both ends. In any case, there's no place for omnidirectionals here. You will need to do either 180-degree patch antennas and maybe 60-degree directional antennas at either end. And again, the most important consideration here is you will need to do a site survey before you deploy and after you deploy to actually assess how well you've done your design. Another use case for deploying patch antennas is in very high design environments. In those environments, what we want to do is we want to reduce the amount of CCI, and because we direct the signal away from maybe where the other access points are or other sources of RF, the directional antenna might be a good tool to move most of the signal away from co-channel interference scenarios. In very high density environments like auditoriums, conference areas, events, you would use directional antennas not only to cover large areas or mount antennas very high up, you will also use it to avoid other sources of radio frequency interference or co-channel interference. A couple of examples: auditoriums, lecture halls, gymnasiums, libraries, cafeterias, any open areas where a lot of people would gather in the same place, and you'd have to deploy multiple access points and worry about other sources of RF as well.